Alright, for your homework help in section 8.5, day 1, we'll take a look at a couple different types of problems using determinants. First one's going to ask us to use a calculator and Cramer's rule to solve this system of equations. We will then use the determinant and the equation that we used for the area of a triangle with the following three vertices. Similar problem, they're going to give us three vertices, only this time we don't know one of the values to figure out what value could be there if I have an area of 6 square units. And then it's just going to ask us to simply find the area of that triangle. So just using determinants. Alright, so let's say on the test you look at problem number 1 here and it says, doesn't say use your calculator, but I would probably give this to you on a calculator part unless it was a smaller problem. It says use your calculator and Cramer's rule to solve this system. Well, if you remember what Cramer's rule is, you have to find a bunch of determinants. So you have to find what we call determinant D, which is really the determinant of the coefficient matrix. So that would be 1, 2, negative 1, and then 2, negative 2, negative 2, and then negative 1, 3, 4. And then I would have to figure out what that determinant is. And that's why they're saying use a calculator, because that would take a little bit of time. Not that it would take forever, but it would take us a little time. Then I have to find D sub x. And what that meant is you took the coefficient matrix and you blocked out the x column and replaced it with the answers. So D sub x would actually be negative 7, negative 8, 8 for that first column. And then you would still have the 2, negative 2, 3. And the negative 1, negative 2, 4. And then you would want to find D sub y, which would mean go to the coefficient matrix and this time block out the y column and again put those answers in. So you're still going to have the 1, 2, negative 1. Now instead of that column you replace it with negative 7, negative 8, 8, and then you'll still have the third column, negative 1, negative 2, 4. And then, of course, I've got to find D sub z as well, which means take the coefficient matrix and block out the z column. So you still should have the x and y column. So still have 1, 2, negative 1. Still have 2, negative 2, 3. And then the z column would become the answers, the negative 7, negative 8, and 8. And so that would be the first thing you'd have to understand is that you're going to have to find those four determinants. And then it says to use a calculator, so they just simply want you to plug in and figure out what the determinant is of each of these. So you're going to have to enter them in kind of one by one. So it's going to take a little bit of time, but it's mostly calculator work. And I guess I would recommend that you always find D first. And the reason for that is, well, let's just find it first and I'll show you why. So typing all these numbers in. Clear out of here, I'm finding the determinants. So remember, go to second matrix, over to math, pick number 1, back in, tell it I want number A or letter A, and the determinant for this thing is negative 18. Now, if I actually want to find out what x is in this setup using Cramer's rule, to find x is going to equal D sub x divided by D. Just like if I wanted to find y is going to equal D sub y divided by D. And z would equal D sub z divided by D. So why do I want to find D first? Well, what's going to happen if D is equal to 0? It means that I can't solve it using Cramer's rule because I can't have D in the denominator. So if you got a problem like this and it says solve using Cramer's rule and you get D equals 0, you can just simply say cannot solve using Cramer's rule. Some of them are just not solvable. Some of them you just can't solve using this rule. And so clearly what I need to do is I need to find all three of these and then divide them. I'm not going to run through and do all of them. I'll go ahead and find D sub x and x. So then I want to go in and I want to plug this into my calculator. So go back into your matrix category, go to edit. Again, tell it you want a 3 by 3. This time negative 7, 2, negative 1. Remember, really I'm just replacing this column, so I can say this is negative 8. Hit enter a couple times. Say this is 8. Hit enter a couple times. Go back to your matrix category under math. Actually, if you look at this, I have it stored in my calculator as determinant A. The calculator knows that's what I'm doing. If I actually just hit enter, the calculator actually found the determinant of this matrix that I just entered back in there. So since I use the same matrix, without me having to actually type in determinant A again, it actually knew what I wanted to do. So I actually know the determinant of this is 54. Just like if I was going to go find d sub y, I would go into matrix, I would edit the exact same one, I would change some numbers around. I'm not going to actually do this, I'm just going to throw some random numbers in there. And then once I get it in there, I hit enter again, it'll calculate it out for me. I don't have to sit there and constantly type in determinant A. Not that that takes that long to do, but it's kind of handy. And then of course if I'm looking for x, I would now say it's 54 over 18. And if you weren't sure what it was, you could type it in your calculator and say, yep, x is equal to 3. And then you just have to go back and do the same thing for y and the same thing for z. And if you do that, I'll just tell you what you should get. D sub y, you should get positive 18. And d sub z, you should end up getting negative 36. So you can go back and double check those if you want to, which means y is eventually going to equal negative 1 and z would eventually equal 2. So Cramer's rule is mostly calculator work. If I asked you to do this by hand, I would probably give you a 2 by 2. Alright, on to the next one. Use the determinant to find the area of a triangle with the following vertices. So hopefully we remember that the area of a triangle is equal to plus or minus 1/2 times the determinant of all of these points. And what you did is you wrote down an x and a y value and then 1, another x and a y value and then 1, another x and a y value and 1. And it doesn't matter which one's which, as long as you put x and y value next to each other. It doesn't matter if this is 0, 1/2, if that's 0, 1/2, that's 0, 1/2, won't make a difference. And then again, just a reminder, that's plus or minus because we don't know if this is going to end up being positive or negative or not. So just know that your final answer has to be positive. So the idea here is that we are going to have the area is equal to plus or minus 1/2 times the determinant of 0 is my x value, 1/2 is my y value, and then 1. 4 is another x value, 3 is a y value, and then 1, 5/2, 0, 1. And now I just need to find the determinant of this and then multiply by either 1/2 or negative 1/2 depending on whether this is positive or negative. And so it's up to you. You can do the expand by row or column thing, or I'm going to do the arrow thing since I like that. Multiplying these three together first is going to give me 0. Taking these two, turning around and grabbing that one, it's 1, so ignore that one. Multiply those two together, it gives me 5/4. And then 1 times, there's a 0 in here, so it doesn't really matter. So I'm going to have 5/4 for my first number. Going the other direction, I have 3 times 1 times 5 over 2, so 15 over 2. And then the other two are easy. It's 1 times 0 times 0, so that's definitely 0. And then 1 times 4 times 1/2 is going to eventually give me 2. And so if I get a common denominator, that's 4 over 2, or that's eventually going to give me 19 over 2. And so my determinant of just that matrix is going to be 5 over 4 minus 19 over 2. Probably want to get a common denominator and say it's 5 over 4 minus 38 over 4, which is going to give me negative 33 over 4. Now that's the determinant of this matrix. Because it's negative, I need to use the negative 1/2, because I don't want to have a negative area. That won't make sense. And that's going to give me a positive 33/8. And that would be my area. Alright, on to the next one, which is similar to this. Going to use the same idea. They give us the 3 vertices, and they tell us the area is equal to 6. Only difference is I don't know what that y value is, but I'm going to set it up the same. I'm going to say it's plus or minus 1/2 times the determinant of 1, 0, and then 1, 5, negative 3, and then 1, and then negative 3y, and then 1. And they're telling us that this is going to equal 6. Now, I usually try to get the determinant part by itself, so I'm going to multiply both sides by plus or minus 2. I have no idea if it's what this is going to be. And because there's a variable in it, I'm going to actually have 2 answers. So I'm going to say that my determinant, I'm not going to actually write all the numbers in, is going to equal plus or minus 12. And so now my job is to try to figure out what is that determinant. So let's do that over here. 1, 0, 1, 5, negative 3, 1, negative 3y, 1. And again, I'm going to do the arrow thing. I kind of like doing it that way. If you want to expand by row or column, you're welcome to do that. Alright, so multiply those 3 numbers together, I get negative 3. Take 1 times 0 times negative 3, that's going to give me 0. 1 times 5 times y should give me 5y. So adding all those together, I'm going to get 5y minus 3. Other direction, multiplying negative 3 times 1 should give me 9. 1 times y times 1 should give me just y, and then 1 times 5 times 0 should give me 0. So that should give me y plus 9. And now remember to find the determinant. You take the one on the bottom here, 5y minus 3, and subtract the one on top, which is a quantity, so make sure you use parentheses. It looks like if I distribute that negative, I would get 4y minus 12. And so I'm going to take 4y minus 12 and set it equal to both positive 12 and negative 12. Since I don't know what y is, there's possibly two numbers. One number would make it positive, one number would make it negative. And now when I solve, for this one I add 12 to both sides, get 24. Here I'm also going to add 12 to both sides and get 0. Divide both sides by 4. I could get y is equal to 6, or I could get y is equal to 0. And if you wanted to take the time and put 6 in here, run through it, you would get one answer. It would end up giving you a determinant of 12, which means you'd use the positive 1/2 to get the 6. Put 0 in here, you would end up getting negative 12 for your determinant, which means you would use the negative 1/2 to get 6. So any problem that looks like this, which you do have one in your homework like this, you should end up with two answers like that. Alright, and then the last problem, again, another variation of finding the area with your triangle. And they give you a triangle, they kind of show you the vertices, they don't tell you what they are, and then they give you a bunch of lengths. And the idea here is, if you're going to use the determinant, you need to have the vertices. So, you need to come up with them. And you might say, well, I don't know how to start, or where do I start? And the nice thing is you can start wherever you want. I'm going to tell you to pick one point on this graph and say it's the origin, if you will. And it doesn't matter where you do this. So I'm going to pretend like that is actually the origin. So think of me on a graph like this. If that's the origin, then this point is 0, 0. Now let's focus on this point. If this is the origin, that distance is 65, which means I move 65 to the right, which means it's the x value. This distance is how far up I move. That means it's the y value. There's the second vertice. Third vertice. From here I had to move a distance of, this distance is 65, so if you move up here, that means that this is 65. Whole thing's 85, so this distance is 20, and you have to move to the left 20. The only thing I would need to know is this distance, and I was supposed to give it to us. I never did. This distance is supposed to be 30. That would be tough if I didn't know that. So this distance is 30. This distance is 50. That means I had to go up a total distance of 80. So sorry about that. That was supposed to be given. And so now I've got the three vertices, and I can run through and I can do this setup. Now, like I said, the wonderful thing is, if you thought that this was your origin right here, and you went through and did the same thing, you would get three different vertices, but they would give you the same area. So kind of the trick for that one is pick one of the points. It doesn't even have to be one of these points. You could have picked this to be the origin if you wanted to. Just pick a point on that graph. I would probably pick one of these three, make it easier, and then go through and do it. So now I've got the area is equal to plus or minus 1/2 times, doesn't matter which order you put these in here, it's 0, 0, 1, it's 65, 51, it's negative 20, 81. And for this one, I'll expand by row by cofactor since I've been doing the arrow thing for everything else. If I was going to do that, I would probably pick that one since of all the zeros. So it's 0, cofactor, that's the first row, first column, won't matter, plus 0, cofactor, first row, second column, that's odd, but it won't matter, and then plus 1, cofactor, first row, third column. So now block out the first row, third column, you've got 1 times this determinant. Now when you look at it, you see these numbers are nowhere near being all that nice to work with. So maybe you want to use your calculator to help you multiply this out. Not that you can't multiply this by hand, it'll just take you a little time. So to speed things up, if I take 65 times 80, or if you're doing it by hand, just multiply by 8 and then add a 0 on, I'm going to get 5,200. Subtract, I can see this is going to be a negative number, so it's going to be adding. 2 times 5 is 10, add the 2 zeros on. And I'm going to get a total of 6,200 times 1. So it's plus or minus 1/2 times that. Obviously, I don't want the negative. I'm going to take half of that, and so my area should be 3,100 square units or square feet or miles or whatever the units are that they give you. So realistically, other than multiplying 65 times 8 and tacking a 0 on to get that number, wouldn't be that difficult to do by hand. Alright, hopefully that helps you out for day 1 homework for 8.5.